Welcome to the potential new survival series. In this video, I will recreate the tree chopping mechanism from the indie survival title Rising World. I will start from the brand new URP project, and by the end of the video, you will have a basic first-person character controller. Then you will have a nice pickup mechanic to pick up this hatchet. Then you can walk up to the tree, chop it down by hitting it multiple times. Then the tree will fall over. Then you can pick up this nice tree stump to gather some wood. Then you can further chop down this tree. Then you can pick up some more logs and branches to collect the resources. And you will also learn how to set up a nice audio manager. For this video, I will try to write clean code as much as I can so that the system can be scalable. Due to that, I will suggest you don't rush things. Treat the video as a course. Take your time instead of completing the video in one sitting. At any point, if you have any question or facing any difficulty, let me know in the comments. Also make sure to include the timestamp so that I know what you're referring to. And for you to follow along, I will provide the asset package that you can download from my Patreon. Don't worry, it will be absolutely free. For the complete project, there will be a separate package. Last thing is, I'm going to cover a lot of things, so I will assume that you know basics of C# and some basic Unity concepts. For the video, I will be using Unity 6. And now with all of that out of the way, let's get started. Okay, so I've created a brand new 3D URP project. Now first, let's do some cleanup. So I'm going to remove the README asset and hit proceed. Then I have this default input actions. I'm going to create my own from the scratch. So let's delete this one as well. Then in the settings folder, there are mobile renderer and render pipeline asset. I'm targeting the PC version, so I'm going to get rid of these two as well. Then I have this default volume profile, which will include the post-processing effect modules. So we'll keep that. And then I have the sample scene profile, which will be this global volume post-processing. So I'm going to keep that as well. And then we have some render pipeline settings, so we're going to keep that as well. Then head over to project settings, and in the graphics section, make sure that I'm using the correct render pipeline asset. Then in this quality section, I'll just get rid of this mobile level, so I'm going to delete it. So we only have PC version for both editor and the final build. Now I'm going to rename this settings folder to RP settings, so render pipeline setting, and I'm going to add a leading underscore so that this folder will always be on the top. Then in the scenes folder, I have the sample scene, which was open here. Okay, so this was the setup for our new project. Okay, now it's time to create our simple first-person controller. So I'm going to create an empty object. I'm going to call it player. Then I'm going to add a component called character controller. Character controller is Unity's built-in solution to handle player movement. Think of this as a motor that drives our player. Then let's focus on our player, and as you can see that it has our pivot in the middle. So let's raise this character controller slightly up. So I'm going to set the offset to 1 in the y-axis so that this controller will have the pivot in the bottom or at the feet. Now our player needs a ground to stand on, so let's create a new plane. So 3D object and plane. I'm going to call it ground. Then let's position it into 0, 0, 0. And let's set the scale to 25 in all 3 axes. Then I don't need this mesh collider, so I'm going to remove it and include a box collider. That will be a slightly less expensive than mesh. Then our ground is supposed to be grass, so let's create a new material, and for that I'm going to create a new folder. So create folder, let's call it materials. And in that, let's create a material called ground. And I'm going to set the color to some green and set the smoothness to 0 and metallic to 0 as well. And let's apply it to our ground. Then in the base map, I'm going to select this checkerboard pattern and let's set the tiling to 25 so that we have some kind of reference to know that our player is indeed moving like this. Then let's take our main camera and set it as the child of our player, and then I'm going to set it to 0, 0, 0, so it will be at our player's feet like this. So let's raise it up with something like 1.7 in the y-axis. So our camera will be positioned at around eye level of our players. And keep in mind that our player's height is 2 meters. Alright, now it's time to define the player inputs. And I'm using the new input system, so I'm going to create a new folder. Let's call it inputs. Then here I'm going to create an input action map, so it will be input actions. Let's also call it input actions. Then we can double click it and it will open this nice window. Here we will define some action maps, so I'm going to create a new player action map. Let's get rid of this default one, and in the action, the first action will be the move action, so let's hit this plus icon and let's go move, and its action type will be value. Then for our move action, let's define some bindings, so hit this plus button and set up, down, left, right composite. Then let's get rid of this empty binding, so select it and hit delete. And for our 2D vector binding, let's rename it to WASD. So I want to move the player with WASD. And then in here for the up binding, let's hit this path and just simply hit this listen button. And now I can type in any key in my keyboard. So W for up, for the down, S. For left, it will be A, and for the right, it will be D. Then our player will have a new action for attack or the X swing. So let's create a new action. Let's call it primary. And this time the action type will be button. And in this binding, let's simply listen to the left click, and we can't. So we will simply go to mouse and then let's use the left button. Then we will have one more action to pick up the objects. So let's create a new action for interact. And its action type will also be button. And for its binding, let's just set it to E key. And make sure to hit the save assets button. Alright, that's all for our input actions for now. So let's close this window. Then select our input action map. And let's check this generate C# class. Then I'm not going to change the file name and the class name, but I like to create a namespace for all my scripts. So I'm going to go and type in a namespace name. Let's call it survival series. And then hit this apply button. It will generate this new input action C# script, which will have our actions defined in it. Alright, now that we have defined our input actions, now let's create a script that will read that inputs from the players. So I'm going to create a new folder. Let's call it scripts. And here I'm going to create a mono behavior script. Let's call it game inputs. Then in our scene, let's create a new empty object. Let's call it game inputs as well. And let's set it to the center of our world, and let's attach our new game input script. And this script will be responsible for reading the input from the user. And in the hierarchy, I like to set it on the very top. And then let's open our script. In my script, I'm going to wrap this game inputs class in a custom namespace. So surround with namespace, and I'm going to call the namespace survival series. And as I mentioned earlier, I like to use a namespace because it will prevent any kind of conflict if I choose to use any third-party asset with the same class name. Then in our game inputs class, let's grab the reference for our input action map. So private input actions, and let's also call it input actions. Then in the awake method, let's initialize our input actions. So input actions equals new input actions. Now our input action has an action map called player, and first we need to enable that. So I'm going to go input actions dot player, and then dot enable. So with this line, now we will be able to read the actions defined in this player action map. Now one important thing is, in my case, this game inputs game object will not going to be destroyed while the game is running, because I only have this sample scene and it won't going to change for this entire video. But if you enable any action maps like this and this game objects get destroyed for any kind of reason while your game is running, that will cause a memory leak. So it's a good idea to disable it. So for that, I'm going to use onDestroy method, which will be called when this game object gets destroyed. And here I'm simply go input action.player.disable, like this. All right, now here let's create a new public method to read the move vectors. So let's go public, and it will return a vector 2 called get move input, and this input vector will be normalized. So let's specify that in our name as well. So normalized. And here I will simply go return input action.clear.move.read value of type vector2, like this one. And now for our primary and interact actions, I'm going to fire an event when we press those buttons. So for that, let's go here and define a public unity action on primary, and one more for on interact. And this unity action is simply a delegate with the void return type, and I personally use the delegates as events rather than using the C# events. And if you don't know what a delegate is, think of them as a variable that can hold a method reference. So in the awake, I'm going to go input actions dot player dot primary dot performed. So when we press the primary button, let's fire off our delegate on primary. So I'm going to go plus equals, and let's simply use the lambda expression. So call the context, and here I'll simply go on primary and invoke, and then use the semicolon. Now one more important thing is, if this on primary doesn't have any methods listening to it, it will cause a null reference exception. So to prevent that, we will first check if on primary not equals null, then do this. Or we can simply write the same thing by simply going on primary (invoke). So this is simply a shorthand for this one. So this question mark will evaluate this expression and check if it is null. If it is, then it won't execute whatever is written in the right side. Otherwise it will. So let's get rid of this and use this. And same thing for the interact. So input actions dot player dot interact dot performed, and here let's simply go on interact question mark dot invoke like this. And this script will be responsible for only one thing: listening to player input. Alright, let's head over to Unity. Now here let's create a new script to control our player. So for that, let's create new mono behavior script. I'm going to call it player, and let's assign it to our player game object, and double click to open our script. Then again, I'm going to wrap the player class into my custom namespace. So surround with namespace, let's call it Survivor Series. Then here let's grab the reference for our game input. So private game inputs, let's also call it game inputs. And I like to assign it from the inspector, so let's simply use the serialized field attribute. Alright, let's save our script, head back to Unity. Here we will have this game input slot. Let's drag and drop our game inputs object. Then in our player script, let's simply create an update method. And here let's simply print the move vector. So let's go debug.log, and here simply go game inputs dot get move input normalized. Okay, let's save and test. So let's hit play, and here you can see that we are printing the move vector, and I will be in a way. So let's do this, and if I hit the W key, you can see that the Y component is returning 1, and if I hit S, yep, it returns -1, and if I hit A, it returns -1 in the x-axis, and if I hit D, it returns +1, and if I hit D and W together, it returns the normalized input. So that's all cool. And now if you're wondering why that move vector is returning the normalized value even though I'm not normalizing it manually, that's because in the input action map for the binding, I'm using the mode digital normalized. So this vector will always return the normalized value. Okay, now we have our move input action. So for that, let's use a start method. And notice that here I'm using the start method and not the awake, because I'm using the reference of some other script. And if we head over to the game inputs, you can see that I'm initializing the input actions in the awake method. And in Unity, there is a chance that this awake gets called after this player script's awake. So in that case, it will return a null reference exception. And obviously we can control the script execution order in the project settings, but I don't like to touch this. So that's why I like to use the start method when accessing the members that are not part of the current class. So this game input is not part of this player class. Alright, now here let's go game inputs dot on primary, and let's subscribe to this event. So for that, I'm going to create a new method called handle on primary, and let's simply create that method. And here let's simply go debug.log primary pressed. And same thing for the interact. So game inputs dot on interact. Let's create new method called handle on interact. And here simply go debug.log interact pressed. Let's test. And again, I will be in a way, so let's make it floating, and let me just collapse it. So as soon as I hit the left click, Yep, we are seeing the primary pressed. You can see here it's 2. Let's just simply clear it. And again, let's hit the left mouse button. Yep, we have primary pressed. And if I hit the E key, yep, we are having interact pressed. So our logic is working. That's pretty cool. Then in our player script, instead of continuously printing our move vector, let's try to actually move our player. And for that, let's grab the reference for the character controller. So private character controller. And let's also call it character controller. Then this character controller is attached onto the same game object. So instead of using serialized field, let's grab it on awake. So character controller equals get component of type character controller. Then here, let's create a new function. Private void move. And here, let's simply grab our move vector first. So we will go vector 2. Let's go move input equals game inputs dot get move input normalized. Now one important thing is we will get the move vector as x and y, but I want to move this character controller in x and z axis. So to do that, let's create a 3D vector. So I'll go vector 3. Let's call it move direction equals new vector 3 of move input.x. Then we don't want to move in y-axis, so 0. And let's simply put it 0f. And in the z-axis, we will go move input.y. And we don't need to normalize that. My stupid AI assistant. Alright, then we will use our move direction and go character controller dot, and here I'm going to use simple move, and then let's simply pass in move direction. And the simple move will move our character controller in this direction. Then here I can multiply it with some number to control my character's speed. So actually let's define our speed as serialized field. So here I'll go serialized field. Let's go private float. Let's call it move speed meter per second. And let's go, I don't know, 5. And in our simple move, instead of using 2, let's use move speed. And we don't have to multiply it with time.delta time to make it frame independent, because this simple move method is doing that for us internally. Alright, then in our update method, we don't need to print the log. Let's simply call our move method. Okay, let's test. And if I try to move, yep, my character controller is indeed moving. And let's simply dock the scene view to the side and let me focus on our player. So if I move, yep, you can see that our player character controller is indeed moving. Okay, that is cool, but now I want to look around with my mouse. So for that, we have to go to our input actions. Then let's create a new action. Let's call it look. And its action type will be value. And let's set the control type to vector 2. Then in our binding, let's go to the mouse and simply use the delta. Then make sure to hit the save assets button. Then in our game input script, let's create a new method to get the look vector. So public, then it will return vector 2. Let's call it get look input. And here I'll simply go return input action dot player dot look dot read value of type vector 2. Then in our player script, let's create a new method. So private void look. Then here again, let's grab our look input. So yep, that will do. And now here, if I move my mouse horizontally, I will get the input in the x-axis. And based on that, I want to rotate my player on the y-axis. So for that, let's first grab the rotation of our player. So here, let's go private vector 3. Let's call it player Eulers or Euler angles. And in the wake, let's grab our player Euler angle. So equals transform dot Euler angles. Then in our look method, let's rotate our player on the y-axis. So for that, I'll simply go player Euler angles dot y plus equals look input dot x, and here I can multiply it with some value to control the look sensitivity. And for that, let's create a new serialized field. So simply serialized field, private float, let's call it look sensitivity. And let's default it to 10. Then here, let's use that. And now to make this rotation frame independent, I have to multiply it with time.delta time. Okay, now we have our rotation angle on the y-axis. Based on that, let's actually rotate our player. So transform.rotation equals, and rotation is a quaternion, so we have to use quaternion.Euler and then simply pass on player Euler angles. And then let's call our look method in the update. Make sure to call it before the move, so look. Alright, let's test. So yep, I can look around using my mouse. Okay, so now I can look around to the sides like this, but I also want to look up and down as well. And for that, we are going to rotate our main camera in the x-axis like this. And since our main camera is child of our parent, we will use the local rotation. So in our player script, let's create a new field. So private vector3 player, or actually camera local Euler angles. And in the awake, let's grab them. So camera local Euler angles equals, and here I can simply use camera.main.transform.local Euler angles. Then in my look method, let's go camera local Euler angles dot x minus equals look input dot y multiply our look sensitivity multiply time.delta time. Okay, so there we have our rotation in the x-axis, but I want to clamp the rotation at some angle. So for that, I'm going to go camera local Euler angles dot x equals mathf dot clamp, and let's clamp our camera Euler angle dot x, and let's use some min and max. And for that, here I'm going to define a new float. Let's call it max angle equals 85. Then here in the minimum, let's go minus max angle and max angle. And now based on this angle, let's actually rotate our camera. And I could use camera.main here again, but let's simply grab a reference to the camera transform. So private transform camera transform, and in the awake, I'll simply go camera transform equals camera.main.transform, and here I'm going to use camera transform instead. And in the look method, here let's go camera transform dot local rotation, and again local rotation is a quaternion, so let's go quaternion dot Euler, and let's pass in our camera local Euler angles. Let's check. So yep, now I can indeed look around with the mouse. Also, one more thing is currently my cursor is all over the place, so let's quickly fix that. So let's head over to the game inputs for now. In the awake, let's simply go cursor dot lock state equals, for now let's go confined, so the mouse pointer won't go outside the game window. Let's test. So let's hit play. So yep, my cursor or mouse pointer is currently confined in the game window, and I can indeed look around with my mouse, so that's pretty cool. And my camera's x-axis angle won't exceed 85 degrees in either of the direction. And to verify that, first I have to select this main camera, but my mouse pointer is currently confined, so I can't go in the hierarchy. So first I have to hit the escape button, then let's select main camera and just check the rotation here. Then let's click back onto the game window, and you can see that the rotation is clamped between 85 and -85. So that's cool. However, now we have one issue. Let's look around in this direction, and now if I try to move forward, yep, my character is going this way. That's because when we look around like this, our player's forward axis will change or rotate. But in our player script, in the move method, this move direction vector is in wall space. So we have to rotate this vector based on our player's rotation. And we can easily rotate this by simply going quaternion.Euler. Let's pass in our player Euler angles and multiply it with our vector. Okay, let's test again. So now if I move forward, yep, my player is moving forward. And now if I look around in this direction and move forward, yep, now the issue has been fixed. And now we have our basic first-person controller. Awesome. Okay, now let's work on the Hatchet. And for that, we need assets. Okay, so I've created this nice package that contains all the asset file for our project. And I will provide this package so you can follow along. Simply check out my Patreon link, and don't worry, this package will be absolutely free. Alright, let's import the package to our project. Let's import everything by hitting this import button. Then our package has been imported. And here I'm simply going to grab this asset folder and drag it out. And then I will simply delete this empty folder. In the asset folder, there is this beginner X folder, which is the asset I've downloaded from the asset store by Santutu. And in that folder, we have this prefabs folder where I've made this prefab, but simply drag and drop it. And this hatchet visual is simply an empty game object which has this handle and blade meshes. And the hatchet visual also has this animator component which has this hatchet controller created by yours truly. And I also created this two animations. So the idle animation is simply a collection of rotation keyframes so that our hatchet will go back and forth like this. And I've also created this strike animation that looks something like this. And the key thing to remember is the idle animation has a loop time enabled and strike doesn't have it. And this hatchet animator controller is set up like this. So we have the default idle animation. Then we have a transition that goes to strike. And this transition has this condition strike, which is simply a trigger parameter. And for the transition, I've disabled the exit time. That simply means don't wait for this idle animation to complete before transitioning to the strike. Then from this strike state, I have a transition that goes to exit, which has this exit time. So wait until the strike animation finished and then go to exit. And after it goes to exit, it goes back into entry and the loop will go on. So let me just show you. So let's hit play and let's dock the animator here. And let me select the hatchet visual. So you can see that right now my hatchet is in the idle state. And if I go to the strike state, yep, it goes to strike, then moves back to idle. So that's our animator controller. Okay, now let's try to play that animation on the left click. And I like to keep the game logic separate from the game visual. So first let's create a new empty game object. Let's call it Hatchet. Let's set its position to 000. Then drag our Hatchet visual and make it the child of our Hatchet. And then let's reset its position as well. So this will be just the visual for our hatchet, and the actual logic will sit on the parent game object. And the main reason to do this is by doing that, you can easily update your visuals without touching your actual game logic. Then I want this hatchet in the hand of our player. So let's create a new empty game object as a child of our player. Let's call it weapon slot. Let's drag it inside the player and let's reset its position. Then let's move it up. Let's bring it slightly forward and then take our hatchet and set it as the child of our weapon slot. And also reset its position. And let's head to the game view. And now let's adjust our weapon slot. So something like this looks nice. Let's just hit play. So we have our hatchet in our hand, and now there's one issue that if I look up and down, I want to move the hatchet along with it. So it's very simple. Let's drag our weapon slot as child of our main camera and test again. So yep, now it looks a lot better. Now let's actually try to swing it by hitting this left mouse button. So to control the animation, let's create a new script. So new mono behavior script. Let's call it Hatchet Visuals, because animations are simply visuals. Then let's attach our script on our Hatchet Visuals prefab. And let's open our script. Then here, first I'm going to wrap the entire thing in a custom namespace. So surround with namespace, survival series. Then here, let's first grab the reference for our animator. So private animator, and let's grab it on a wake. So animator equal get component of type animator. Now to change the state from idle to strike, let's create a new method. And we will call this method from outside this class. So public void, let's say strike, and here simply go animator.setTrigger, and our trigger was strike indeed, and the string will be case sensitive, and when using string literals it is very easy to make a mistake and it won't even throw an error. So be very careful to match this with our trigger parameter name. So instead of directly passing the string literal like this, let's come up here and I'll go private constant string. Let's call it strike trigger and pass in our trigger name like this. And then here I'm going to use the variable strike trigger. So if I were to set the strike trigger multiple times, I only have to check the spelling once. And I wrote this const keyword, that means constant. That's because our strike trigger value won't going to change during the entire runtime of our game. And now for the actual game logic, let's create a new script. And let's call it Hatchet. And this time assign it to our Hatchet game object. And double click to open it up. Then here, again, I'm going to wrap it in the namespace. Then here, let's first grab the reference for our Hatchet visual. So private Hatchet visual, let's also call it Hatchet visuals. And let's grab it on a wake. So Hatchet visuals. And the Hatchet visuals is attached onto the child of our game object. So let's go get component in children of type Hatchet visuals. Then let's create a new method and we will call this method from outside the class. So public void, and let's also call it strike. And here, let's simply call our Hatchet visual strike method. And we will call the strike method from our player script. So first, let's grab the reference for our Hatchet. So here, I'll simply go serialize field, private Hatchet. Let's call it current weapon. In Unity, let's select our player, and in the player script, we will have this new current weapon slot. Let's drag our Hatchet. Then in our handle on primary, we no longer need to print the message. Let's simply go current weapon dot strike. Okay, let's test. So when I hit the left click, yep, our swing animation is playing. And now currently the mouse pointer is all over the place and it looks fairly distracting, so let's fix that first. So let's head over to our game input script. Here, instead of confined lock state, let's simply go locked. So the mouse pointer will be locked at the center of the game window, and it also automatically hides it for us. So now we no longer see the mouse pointer, and if I hit the left click, yep, our swing animation is playing nicely. But there's one issue. If I double click, our swing animation is playing twice, and as a player, it will feel as a horrible input lag. So to prevent that, in our Hatchet script, I only want to call the strike method if our strike animation has finished playing. One potential fix is to update our strike animation itself. So at the end of our strike animation, we can add an event like this. And on this event, I can fire off a method from any script sitting on the current game object. So here we have Hatchet visuals, and in the method, I can subscribe to the strike method, or I can create a new method and do that. But this approach will force me to combine the visual logic to the actual game logic, and I don't really like that, so let's simply remove it. And instead of touching the animation, let's add some kind of delay in our actual game logic. So our strike animation is exactly ½ second long. So in our Hatchet script, let's add some kind of delay. So if we call this method, we won't be able to call it unless that timer is expired. So first, let me declare one field. So private constant float. Let's call it strike delay. And let's go 0.35. Then let's create one more field to track the time. So private float strike timer. Well, let's default it to 0. Then we also need to know if we're tracking the time currently or not. So let's create one more Boolean variable. So private bool is strike timer ticking. And let's set it to false. Then in the strike method, first we will check if is strike timer is ticking. If so, simply return. Otherwise, let's reset our strike timer. So set it to 0. Then let's set our boolean to true. So is strike timer ticking to true. And then we will play the strike animation. Then let's create update. Then here, first we will check if is strike timer is ticking. Then we will update our float. So strike timer plus equals time.delta time. And then simply check if strike timer is greater than equals our strike delay. Simply set our boolean to false. So just like this. All right, let's test. So if I click once, yep, our animation is playing. But if I double click, yep, it only plays once. So our logic is working. Now in our Hatchet script, currently on the strike method, we're only playing the animation. That will change in a bit. But first, let's create some trees. So for the trees, in the assets folder, there's this mobile white birch tree, which I've downloaded from the asset store by next spring. So in the models folder, we have this complete tree, which is provided by the next spring. But I've created some other models as well based on this tree. So I have this cut tree, which is slightly shortened version of the original tree. Then I've created this tree log as well. And I've also created this tree stump. And this branch visual is simply a prefab with 2 quads with the leaf material like this. Alright, so in our scene, let's drag in our tree intact model. Then again, let's separate the game logic from the visual. So let's create a new empty game object. Let's call it tree or birch tree. Let's reset its transform. And let's set the tree intact as the child of the birch tree. And let's reset its position and rotation. Then on our birch tree, let's attach a capsule collider. And let's set it to roughly match our tree trunk. So something like this. Then let's create a new script. Let's call it Birch Tree. And let's assign it to our Birch Tree game object. And let's open our script. Here again, I'm going to wrap it in my namespace. Let's call it Survival Series. Then here, let's first define our tree's health. So private float health. And let's set it to 125. Or let's use int as our health. Then let's create a public method to take damage. So public void take damage. And let's receive the damage amount as a parameter. So int damage. Then here simply subtract the damage from the health. Then we will check if health is less than equal 0. So first let's set the health to 0. And let's simply destroy our game object. So destroy game object. Now we will call this method from our Hatchet script. So in the strike method, after playing the visual, let's check for collision. So let's create a new method called check collision. And let me create that method here. Then here I'm going to create a new box in front of our player. So let's go vector3 box position, which will be transform.position. So currently our hatchet position, and let's move it half a meter in front. So transform dot forward multiply 0.5. Then let's define the size of our box. So again, vector3, let's call it half extent. So let's go new vector3. Then let's say I want the box to be 1 meter wide in x-axis, so 0.5f. And I want the box to be 1 meter tall, so again 0.5f. And then I want the box to be 2 meters wide in z-axis, so 1f. Then let's go physics dot overlap box. Then let's pass in our box position, then our box size, so half extent. And we also have to pass the rotation, and I want the rotation to be the same as transform.rotation. And this method will return the array of collider that are within our box. So let's grab them. So collider array colliders equals that. Then let's loop through the colliders. So for each our colliders, let's set the type to collider and let's call it target. Then here we will check if our target collider has the Birch Tree component. So if target dot target component, then let's go out Birch Tree, our tree. So this try-get component method will check if our target has this Birch Tree component. If it has, it will return true and the component will be stored in this variable. Alright, then here simply go tree dot take damage, and here we will define the damage. So for that, let's actually define the field. So private int damage of, let's say, 25. Then let's pass in our damage here. Actually, let's go to our take damage method and simply print out the health. So debug.log health. Alright, let's test. Okay, so let's walk up to our tree. Let's swing. So yep, current health is 100, then 75, 50, 25, and now if I hit, our tree should be destroyed. So yep, it's gone. But now we have one issue. Let's undock this console. So right now, again, our animation and the game logic is not matching. So when the axe is winding behind, our tree is taking damage. See? So as you saw, our tree got destroyed before our axe could reach its trunk. So let's try to fix that. So for that, in our Hatchet script, instead of calling our check collision method here, let's call it in our update method after our timer expires. So right here. Alright, let's test again. Alright, so let's walk up to the tree and let's swing. So yep, now our animation is in sync with our game logic. So we are receiving damage after the animation. So yeah, it's working. Okay, now first let's create a prefab for our tree. So let's create a new folder. Let's call it prefabs. And simply drag our tree here. And I'll do the same thing for our hatchet as well. Then in our scene, let's create a couple more trees. So simply drag in our prefab. Let's add some various rotation for some variety. Yep, something like this will work. And let's organize our scene. So I'm going to create a new empty game object. Let's call it environment. Let's reset its transform. And let's take our ground and all our trees and make it as the child of the environment. Alright, so now we have multiple trees and I can walk up to the tree and chop it down. And now as you can see, our tree is basically getting Thanos snapped when its health reaches 0. We obviously need to chop it down. So let's do that. So the way I will do that is when our tree reaches the health of 0, before we destroy this tree, we will spawn the tree stump and this tree cut model in the place of our tree intact. And as usual, let's separate the logic from the visual. So let's create a new empty game object. Let's call it tree stump. Let's reset its transform. Grab our tree stump and make it as the child of our empty game object. And let's reset its transform. So now I have this tree stump. And I'll do the same thing for this cut model. So new empty game object, let's call it tree cut. Reset its transform. Grab our tree cut model and make it as the child of our empty game object and reset its transform. So now we have this cut version of tree and the tree stump. Now notice that for the tree cut, its pivot is down on this plane. So I don't want to do that, so I will bring this tree model down slightly. So something like this, so that its pivot is on the base. And when we spawn this object, we will spawn it slightly above like this. Alright, now let's attach some colliders. So in the tree cut empty game object, add new capsule collider. And let's roughly match the trees. So something like this. And we will do the same thing for tree stump. So in the empty game object, add capsule collider. Let's roughly match its shape. Yep, so something like this. Now I want this tree cut version to fall over with the help of physics, so let's attach a rigid body component as well. Let's set its mass to 800, so roughly 800 kilograms. Then let's set the linear damping to 0.02 and set the angular damping to 2. And these two are basically resistance. Then let's set the interpolation to interpolate. So this will smooth out our physics. Alright, now let's make these two as prefabs. So let's simply drag these two in our prefabs. And let's get rid of these two. Then in the Birch Tree script, before we destroy our intact tree, let's spawn the cut version and our tree stump. So let's first grab the reference. So serialize field. For now, let's go private game object, cut tree prefab, and one more for tree stump. And let's simply spawn them before we destroy this tree. So simply go instantiate. Let's first instantiate our stump. So tree stump prefab. Then I have to pass the position where I want to spawn it. So I want to spawn it on current position. So transform.position. And then I also have to pass the rotation. And I want the rotation to match our current tree. So again, transform.rotation. And same thing for our cut tree version. So again, instantiate cut tree prefab on our current position and our current rotation. Now one thing is we have to raise the cut tree version slightly above. So for that, I'm going to create new vector 3. So vector 3, let's go cut tree offset, new vector 3 of 0. Then on the y it was like 0.49 and again 0. Then here simply add it, so plus cut tree offset. All right, let's save. In the Unity, now we will see these two slots. Now instead of assigning it here, simply open the prefab. Then here we will assign the reference. So let's drag our cut tree and assign it here. And for the tree stump, let's assign it here. Save. Let's move back out of the prefab. So now every single prefab will have the reference. All right, pretty cool. Now let's test. Okay, so let's walk up to the tree and chop it down. And when the tree destroyed, we get the stump and our cut tree version and it falls over. So that's nice. Now one thing is currently my tree is falling in random direction, but what I want is, let's say if my player is cutting the tree from this side, I want the tree to fall over like this. So to do that, what I'm going to do is I'm going to add a twisting force when instantiating the cut tree version. So for that, let's head back to our Birch Tree script. Now here, to add the force, I want the reference of the rigid body. So to get that, for the cut tree prefab, instead of using the game object type, I'm going to change it to rigid body. Then this instantiate method also returns the type of our prefab. So let's grab our rigid body here. So I'll go rigid body, let's call it tree equals this. So sorry, I made the mistake. I have to do this on the cut tree prefab. Then to add the twisting force, I can go tree dot add torque, but here I want the tree to fall relative to player, so instead of add torque, let's go add relative torque, like this. And now before I can apply the torque, I need a reference to my player transform. So for that, we'll get that in the take damage method as parameters. So I'll simply go transform. Let's go attacker transform. Then here I'll simply go attacker transform dot right, and let's apply some force as well. So I'll go float torque equals 2f and multiply it here. And now I want to apply the force instantly, so I'll go and pass in the force mode velocity change. And in the Hatchet script, we are going to get the error in this take damage method because we have changed its signature. So now I have to pass the transform as well. So the question is, how do we get the player transform? So for now, let's cheat a bit, and here I'll go private transform player transform, and let's grab it on awake. So I'll go player transform equals camera.main.transform. So this is our camera's transform, but we want player transform, so let's simply go dot parent. Now this is bad, and I'm going to fix that in a bit, but just to implement the functionality, let's go and pass that in our take damage method. So player transform. All right, let's test. So let's cut the tree, and currently our tree is falling towards us. We want to do opposite of that. So in the Birch Tree script, instead of using the right, let's simply invert it using the minus sign. Okay, so let's test again. So I'll go and walk over like this, and let me cut it. So yeah, our logic kind of works. Let's go to another tree. And we have invalid cast exception. Birch Tree, line number 70. Oh yes. So we are receiving the error because I've changed the type from game object to rigid body. So if you do that, in the Birch Tree prefab, you have to reassign the reference even though it is showing the correct reference. So let's go and go select none, and then again drag our cut tree. Just Unity things. All right, let's test again. All right, let's walk up to the tree, cut it down, and let's walk up to this tree and cut it down. So yeah, we no longer have error, but our logic is not working. Alright, so the reason why our logic is not working was because I made a very silly mistake. Right now I'm using the attacker transforms right, which is the right axis or x-axis of our player, but that is in the world space. So instead of using relative torque, let's simply use add torque. Alright, let's test again. Okay, so let's walk up to the tree, cut it down, and yep, now it is falling towards me again. Let's check here. If it falls towards me, we will simply flip the axis. Yep. So in the script, simply use attack transform.write. Let's test again. So now our logic is working. Okay, cool. But now what I want is, I want to chop down this cut tree as well. So for that, let's create a new script. Let's call it Birch Tree cut. Go to the prefabs folder, and in this tree cut, assign our script. In the script, first I'm going to wrap it with the namespace. So surround with namespace, survival series. Then here, again similar to Birch Tree, let's define the help and let's define the take damage method. So let's go private int help. Let's set it to 100 this time. Then let's create a new method. So public void take damage, and we'll receive the damage as parameter. And let's reduce the health. Then let's check if health is less than equals 0. Then here we can clamp the health to 0, but we are simply going to destroy the object. So let's simply go destroy game object. Then we will call this method from the Hatchet script. So in the check collision method, here we are casting a box and getting the colliders that are within that box. Then we are looping through every collider and checking if the target has our Birch Tree. Then do this. Now here I can do another if and go target dot try get component of type Birch Tree cut. So this approach could work, but imagine that if I have 10 different objects that could take damage, this approach will become cumbersome. So to avoid that, I'm going to use interface. So let's delete it. In Unity, let's create a new script. Let's call it damageable. Open our script. Here I'm going to wrap it with the namespace. Then this damageable is an interface, so instead of class, I'll simply go interface, and it won't inherit mono behavior. So let's get rid of that. And I want the I to be capital, so I'm going to refactor it. So damageable. Then here I'm going to declare a method signature. So simply public void take damage. We will receive damage as parameter, and again transform attacker transform. Then let's head over to the Birch Tree script. Then here we will implement our newly created interface. So I'll simply go damageable, and here we already have defined our take damage method, so that's all cool. And let's get rid of this log. Then let's head over to the Birch Tree cut class. Here we will again going to implement damageable. And as soon as we implement that interface, we are getting this error that basically says that, hey, you're not implementing this take damage method. So here, let's simply match our method signature with the interface method. So simply add in a new parameter, transform. Let's call it attacker transform. Okay, so error is gone. Now here, let's print our remaining health. So debug.log health. Then back to the Hatchet script. In the try get component, instead of getting the Birch Tree component, let's simply grab damageable component. And now this tree name doesn't make any sense, so let's refactor that. So let's call it damageable. So this will work for both our entire tree and the cut tree version as well. All right, let's test. So let's chop down this tree. So now we have our cut tree version. Let's chop that down too. And yep, our logic is working because it is printing the remaining health. And now it should get destroyed. So yep, our logic is working. However, now we have a tiny little issue. Let me just show you. So when I cut this tree, its trunk jumped over towards me. I don't really want to do that. So basically what's happening is, let me grab this stump and the cut tree version. So currently what's happening is our tree is falling like this. I don't want that. I want it to fall like this. So to do that, I can play around with the center of mass of our rigid body. So first let's get rid of these two. Then let's open up our tree cut prefab. Then here in the rigid body component, I'm going to uncheck this automatic center of mass. It will allow me to set up a custom center of mass. So currently it's at the origin, so that's all cool. And just with that, let's test again. Okay, so let's cut down this tree. And we have this weird behavior. But the initial fall was as we intended. But now the tree is standing back up because the center of mass is always staying at the base. So to prevent that, what I'm going to do is, in the script, I'm going to enable this automatic center of mass after some time. So let's open our Birch Tree cut script. Then here first we'll grab the reference of our rigid body. So private rigid body, let's call it rigid body. Then let's grab that on awake. So rigid body equals get component of type rigid body. Then let's create a method to set the center of mass. So private void set center of mass auto. Then here I'll simply go rigid body dot automatic center of mass equals true. And I want to call this method after some delay, so let's create a new field. Let's go private const float center of mass delay, and let's make it 2 seconds. Then in the awake, I'm simply going to go invoke, and the invoke method will take the method name as string, but strings are very error prone, so I'm going to go name of, and then let's go set center of mass auto, and then I have to pass in the time, so center of mass delay, and the name of, as you can guess, will return the name of any type or method as string. And this invoke method basically means call this method after this amount of time. Okay, let's test. So let's cut down this tree. So yeah, now it's feeling much better. But seems like we have to tweak the delay. Okay, so after some testing, I think that the delay of 0.7 works nice. Alright, now what I want to do is, when we destroy this cut tree version, I want to spawn some logs and some branches. So first for the log, let's drag in our tree log model. Then again, I want to separate the logic from the visual, so let's create a new empty object. Let's call it log. Let's reset its transform. Set tree log as a child of our log and reset its transform. Then this log is a physics object, so first let's create a collider. Let's go with capsule collider. Let's roughly match its shape. So something like this. And then let's add a rigid body component. Let's set the mass to 25. Let's set the damping to 0.1 and angular damping to 0.2. And let's set the interpolate to interpolate. Okay, so this will be our log. Let's make a prefab out of it. So simply drag it here. And let's get rid of our log. Then let's drag in our branch visual prefab. And then let's create new empty object. Let's call it branch. Reset its transform. Take our branch visual and set it as the child. Reset its transform. Then our branch will be a physics object, and for this one let's set up multiple colliders. So first let's go box collider. Let's set it something like this. And one more sphere collider this time. And let's set up like this. So yeah, this will work. Now let's add a rigid body component, and its mass will be 1, linear damping 0.1, angular damping 0.2, and set it to interpolate. Alright, let's make it as a prefab, so let's drag it in and get rid of it here. Then in our Birch Tree cut script, we will follow the same logic that we have done in Birch Tree. So here let's grab the reference for our prefab. So serialize field, private game object, our log prefab, and our branch prefab. In Unity, select our tree cut prefab, and in the Birch Tree cut component, let's assign our references. So let's grab the log, and let's grab the branch. Then in our script, in the take damage function, before we destroy our game object, let's spawn our branch and log. So for that, let's create a new method called spawn log and branches. Then here I want to spawn 5 logs. So for that, let's create an end log to spawn. Let's go 5. And same thing for the branches. So I want to spawn 4 branches. So branch to spawn. Then let's create a for loop. So 4. Then in the loop, we'll simply go instantiate. Then pass in our log prefab. Then the position, let's pass transform.position. And for the rotation, let's simply pass transform.rotation. However, this will spawn all logs on the same position. I don't really want that, so before our loop, I'm going to go vector3 log position equals transform.position, and another vector3 log offset, and I want the offset to be like 60 centimeters. So transform.up multiply 0.6f. Then here let's pass in our log position, and then let's update our log position. So log position plus equals log offset. Then for the branches, I'm going to do the same thing. So I'm going to create another for loop, this time branch to spawn. Then for our branch position, let's first define a vector3 branch position, and I want the branches to spawn at around 3.5 meters relative to the cut tree. So transform.position plus transform.up multiply 3.5. Then here let's set some random position for each branch relative to our branch position. So let's go vector3 random position equals random dot inside unit circle. And for the magnitude, let's go float random amplitude. Let's go 2 meters and multiply it here. Alright, now we have a random position, but the y could go negative, and if that happens, our branch will fall below the ground. I don't want that, so I'll simply go random position dot y equals mathf dot absolute of random position dot y. So the absolute will simply return the absolute value or unsigned value. So the y will always be positive. And then we'll simply go instantiate. Let's pass in our branch prefab with our random position plus branch position and transform.rotation. All right, let's test. Okay, so let's cut down this tree. Let's chop it down. And yep, it spawned 5 logs and 4 branches, so our logic is working. Pretty cool. And now I want the ability to collect all these resources. But before we do that, first let's create a simple crosshair, because currently I don't know where my player is looking at. So in the scene, let's create a new canvas. In the canvas scaler component, set the scale mode to scale with screen size. And for the reference resolution, I'm simply going to go 1440p, so 2560 and 1440. Then the screen match mode is good. Let's set the match value to height. This means only scale the UI when the screen height changes. Alright, then in our canvas, let's create new image. Let's set the source image to knob, and let's set some yellowish color. For the width and height, let's set 20. Then let's rename it to crosshair. So we have our nice crosshair. And while we are here, let's fix our ground material. So we no longer need this checkerboard. And let's set some normal map to create an illusion of uneven ground. So this trunk normal will do. And actually, let's set the scale to 400 and 300. And set the normal map strength to 0.6. And let's darken the color a bit. So yeah, something like this looks good. Alright, so let me cut down this tree. And let's chop it down. Okay, so we have a bunch of resources here. So essentially what I want is to implement a functionality so that I can pick up every single resource. But as you can see, we have different type of resource. So this tree branch, this log, this tree stump. So the question is, how do we implement that functionality? So should we create multiple scripts for different type of resource? That approach could work, but in my opinion, there is no need to do that. So we will create only a single script. Let's call it collectible. Let's open our script. I'm going to wrap it with my namespace. Then here I'm going to implement a method, so public void collect. And here I'm going to simply destroy the game object, so destroy game object. Then in Unity, let's apply that script for our collectible objects. So this branch, let's add component collectible. For our log, we will do the same thing. And our tree stump is also collectible, so just like that. Then I'm going to call this collect method from our player script. So in the player script, let's go to handle on interact. Here we don't need to print this message. And here I'm going to do a box cast from our camera in the forward direction for like 2.5 meters. So first let's go float max distance. Let's go 2.5 meters. Now here I have to define the size of my box, so vector 3 half extents, and I want the box to be 10 centimeters wide, so new vector 3. Let's go 0.05f for all three axes. Then I will go physics dot box cast. Then we have to define the position, that will be our camera's position, so camera transform dot position. Then pass in our half extents, so box size. Then the direction, that will be camera's forward direction, so camera transform dot forward. Then let's get the results, so out raycast hit. Let's call it hit. Then I have to define the orientation for our box, so again that will be camera transform dot rotation, and pass in our distance. Then here I'm going to check if hit dot collider. If it is not null, we have hit something. Then here I'm going to do pretty much the same thing that we have done in the Hatchet script. So here I'll go if hit dot collider dot try get component, and the type will be collectible. Let's call it collectible as well. And here I'm going to go collectible dot collect. Okay, so let's test. Let's jump down this tree. And now if I press the interact key, I should be able to pick up the stump. So yep. Then let's chop down our tree. Then I should be able to pick everything here. So yep, our logic is working. Now today I'm not going to create a full-fledged inventory system because that's simply out of the scope for this video. But still, I would like to know what kind of object or what kind of resource I've collected. So for that, I'm going to create an enum type. So I'll go public enum. Let's call it resource type. Now enums are one of the few types where I start with public access modifier, because oftentimes you will find yourself comparing those types outside the current class, and you will know which access modifier to use with experience. But let's say if you're unsure, always start with private, then go protected, then public. Alright, now here let's define our resource type. So one is branch, then the other type is wood. So our tree stump and log both are wood, so currently it's only two types. Then let's create a variable to hold our resource type. So private resource type. Let's also go resource type, and we will set it from the inspector, so serialize field. Then let's also define quantity for our resource. So again, let's go serialize field, private int. Let's simply call it amount and default it to 1. Then in our collect method, let's simply print what we have collected. So debug.log. Let's go collected this amount of this resource. Now in Unity, for our collectible objects, let's set the values. So for the branch, let's set the amount to 1 for now, and resource type is branch. Then for the log, resource type is wood, and same thing for this tree stump. Alright, let's test. So let's chop down this tree. So let's collect the wood, and yep, it says collected 1 wood. Again, let's chop down this tree further. Let me collect this log, and again collected 1 wood. And if I pick up the branch, yep, collected 1 branch. So that's all cool. Alright, now I want my hatchet to also be a collectible. Basically, I want the functionality to pick it up and set it as my weapon. And to do that, I'm going to use inheritance. But first, let's detach our hatchet. Then let's also add a box collider. Let's set it up properly. First, let's reset the transform. Then I'll go so something like this. And now I want this box collider component to be the part of my original prefab, so I'll come up to this overrides, select the box collider, and simply hit apply to prefab. Alright, now let's lay our hatchet down somewhere. So something like this. Let's raise it up a bit. Okay. Let's move it to the side. Then in our hatchet class, instead of deriving it from the mono behavior, let's go collectible. So by doing that, our hatchet also has this collect method. But now if I try to collect my hatchet just like this, it's going to get destroyed. I don't want that, so what I'm going to do is I'm going to override this collect method in the hatchet script. So here, let's go public. Then I'm going to override the method, so I'll go override void collect. And here I'm having this error. That's because to override the method, first I need to set it as virtual. So just like that. Then back to our hatchet script. Let's set it as the current weapon for our player. So first let's go to the player script. Here I've defined this current weapon field. Now I no longer want to set it from the inspector, so I'm going to do this. And here I'm going to define a new public method. So public void set weapon. And we will receive weapon as parameters. So basically hatchet. Because currently we only have hatchet. But let's rename it to weapon. Then here I'll simply go current weapon equals weapon. And initially this current weapon will be null, so on handle primary I'll simply check if current weapon is null. If so, simply return. Then back to my hatchet script. In this collect method, I want to call my player's set weapon method, but I don't have a reference to that, so how do I get that? So instead of using collect without any parameter, let's also define who collected the resource. So simply go player type who, so who collected. And then I also have to go back to the collectible class and do the same thing. So player who. Then in the player class, I'm going to get the error because here I have to pass who collected the resource. So simply go with this. Then in the hatchet script, here I'll simply go who.setWeapon. Then I'm going to go this because there's hatchet. Now currently there won't be a functionality to drop the weapon. So for now, let's simply destroy our box collider when we collect the weapon. So first, let's grab the reference to our box collider. So private box collider. Then let's grab it on a wake. So box collider equals get component of that box collider. Now, do you remember I've said that for this player transform, this is bad. So let's fix that. So I'll simply go in the collected and simply go player transform equals who.transform. And now that I think about it, this player transform name doesn't make much sense. So I'll simply go owner transform. And now let's destroy our collider. So simply go destroy box collider. And now when I pick this hatchet, I want to parent it to this weapon slot. So for that, in our player script, we need reference to this weapon slot. So let's go to the player script, and here I'll simply go /field private transform weapon slot, then where we set the current weapon. Here first let's parent it to our weapon slot. So I'll go weapon dot transform dot set parent, pass in the weapon slot, then I'll go weapon dot transform dot local position, and let's set it to 0, so vector 3 0. Same thing for the rotation, so again weapon dot transform dot local rotation, and to say 0 0 0 we'll simply go quaternion dot identity. Alright, let's test. Alright, now the one issue is my axe is playing the idle animation when it's lying on the ground. I don't want that, so to fix that, let's open our prefab. In the hatchet visual, let's disable our animator. Then in the hatchet visual script, let's create a method to enable our animator. So here I'll go public void enable animator, and here simply go animator dot enable equals true. Then in the hatchet script, in the collect method, here we will call hatchet visual dot enable animator. Okay, let's test again. Okay, so there we have our hatchet, but first when I left click, yep, nothing happens, so no error. That's pretty cool. Now let's walk up to the hatchet and let's try to pick it up. Okay, I picked up the hatchet, but where is it? Okay, so it's at the origin of our world, so why is that? So in the player script, in the set weapon, everything looks okay, so what is it? Oh yeah, I forgot to assign the weapon slot. So let's drag it and assign it into the weapon slot. Alright, let's test again. Alright, so there we have our hatchet and it's no longer playing the animation. Now let's walk up to our hatchet. Let's pick it up. And yep, I successfully pick up the hatchet. And now I can swing with the left click. Let's try to chop down this tree. Let's pick up our stump. Let's chop down the tree. Let's pick up the resources. And yep, everything seems to work. Now currently there is no proper inventory system, but still when I pick up this hatchet, I would like to know what I've picked up. So when we pick up this hatchet, let's print out the message. So for that, let's go to our hatchet script. In the collect method, here simply go debug.log, and I'll go collected our amount and our resource type. Now as you can see, I'm getting this error. That's because in the collectible for our amount and resource type, I've set the access modifier to private. So private means only this class can access these two variables. Now in my case, I don't want these two to be accessible outside the class, but I want them to be accessible for the class that inherits our collectible class. So for that, let's simply change the access modifier to protected. Then in our enum, let's add the hatchet type, so hatchet. And now in the hatchet class, the error is gone. Then in Unity for our hatchet, let's set the proper resource type, so hatchet. Alright, now I've set up the correct value, but I've done that for only this hatchet. I want to set it for my actual prefab, so simply hover over the property, right click, and then go apply to prefab. Alright, let's test. Alright, there's our Hatchet. Let's pick it up. And yep, there's a message, collected 1 Hatchet. Pretty cool. And with this, we have successfully implemented the core functionality or core game logic. There's no game right now, so core game mechanic. And now if you're wondering that for seemingly very little functionality, we have wrote a lot of code. So yeah, fair point, but understand that I try to write this code as properly as I can so that the system can be easily scalable. Sure, it is time consuming, like even I'm sitting here for like 3-4 hours and I'm supposed to be an experienced guy here, so yes, it is time consuming, but understand that more often than not, the quick and dirty approach is where you will waste the most amount of time. So try to write the code properly from the get-go or from the very beginning. Now unfortunately in this video I cannot show you the real potential of this approach, but if this series will take off in the future, I will definitely create a little survival crafting prototype on top of this one, so you can see that how easy it is to scale the system, how easy it is to build new functionality without breaking the previous one. So do let me know in the comments. Okay, so we have our entire system, but still our game feels a bit bland. That's because we're still missing little touch-up and most importantly the audio. And audio is one of the most important part of the game or game dev in general, but for some reason oftentimes we put it in the back burner. In my personal project I implement the audios along with the actual game logic, so just to give you an example, let's say when we implement this Hatchet swing animation, right after that I would implement the audio logic. Now I've decided to implement the audio at this point in time because at the end of the day this is a tutorial and it would be easier for me to explain here. But in your personal project you should implement the audio along with the game logic. Alright, now for the audio we only have this sound effects which are downloaded from the opengamearts.org. Now these are all very simple sound effects, so I'm not going to create audio sources for everything, but let's say we are implementing a complex sound, then I would probably go into my prefab, then here I would add a new empty object as the child and add an audio component, or in the visuals I will add an audio source like this. That right now all I have is a simple 3D sound effects. So for that I'm going to create an audio manager. So in the script, let's create a new script. Let's call it audio manager. Then in our scene, let's create a new empty object. Let's call it audio manager as well. Let's reset its transform and attach our audio manager script. And I like to keep it at the top of our hierarchy. Alright, let's open our script. Let me wrap it in the namespace. Now first let's try to implement the X-swing sound. So for the X-swing we have 3 different sounds which are modified to match with our swing animation. So when we swing the X, I'm going to play any random sound out of these 3. So in our script, let's create an audio clip array. So serialize field, private audio clip array. Let's call it X swings. Then here, let's create a method, private void play sound. It will receive audio clip, a 3D position, so vector 3 position, and it will also receive a volume, so float volume, and let's also give a default argument, so 1f. So this means if I don't pass this volume argument, it will take this default value. Then here audio source has a nice static method, so I'll go audio source dot play clip at point and then pass in our parameters just like that. Then let's also create an overload version. So again, private void play sound, and this time it will receive audio clip array, clips, then position and volume. Then here first we will grab the random index, so int index equals random.range from 0 to the clip length. And now both these parameters are int. That means that if this clip size is 3, so I will get the random value from 0, 1, 2. 3 is excluded basically. Then simply call our play sound with our clips and our random index, and the position and volume. Then here let's create a public method, the public void play x swing. Then for the parameter let's pass a 3D position and a volume. Then here I'm simply going to call this version of the play sound, so simply play sound with our x swings, position and volume. Then I like to call this method from our Hatchet visual where we are firing this strike animation. So for that, here I could create a reference for the audio manager. That will work, but I'm going to use this audio manager in a lot of places. So instead of defining a reference for our audio manager in different places, I'm going to use something called singleton pattern. And singleton pattern basically means only one instance of our audio manager will exist during the entire runtime of our game. So for that, let's go public static audio manager instance. And now with using the public access modifier, we have to be careful because other classes can read from the instance and also write to it. I don't want that, so I'm going to make it as a property with public get and private set. And the static keyword simply means this instance will be tied to the actual audio manager class and not its objects. Alright, then let's initialize our instance. So for that, I'm going to create a wake and simply go instance equals this. And now I only have a single scene, so it does not matter. But let's say I don't want this object to get destroyed when we change the scene. So I'll simply go don't destroy on load and pass in the game object. So with this line, this audio manager game object will not be destroyed when we change the scene. Now again, I only have one scene, but for example, I have scene 1 and scene 2, and then I've created the audio manager in both the scene. So when we change the scene from scene 1 to scene 2, there will be the audio manager from scene 1, and there will also be an audio manager from scene 2. We don't want to encounter that scenario. So before doing all of this, I'm going to check if instance is not null, so it has some values, then simply destroy this game object and return. Alright, now let's go to our Hatchet visuals, and in the strike method, after we play the animation, let's go audio manager dot instance dot play x swing, and then we will pass in the position. That will be our current position, so transform dot position. Now in Unity we will have this x swing array, so let's populate that. So I'll lock the inspector, then simply drag all three of them and put it here. Then let me unlock it. Let's save and test. Alright, let's pick up our hatchet. Let's try to swing. And yep, our sound is indeed playing. Alright, so now let's implement the remaining sounds. So we have sound for item pickup, tree falling, and when we hit the tree, we will have 4 sounds for that. So in the audio manager script, let's define fields for our audio clips. So I have 4 clips for cut tree impact, so simply go impact or X impact. Then I have one clip for tree fall, so simply audio clip, tree fall, and one more for item pickup. So then in Unity, let's assign the reference. So let me log the inspector. Let's drag all impact sounds. Then for the tree fall and item pickup, let's unlock the inspector. Then in the audio manager, let's define methods to play different sounds. So first, public void play x impact. Again, it will receive 3D position and a volume. Then here, let's simply go play sound, pass in x impact with position and volume. Then one more, public void play tree fall, again with the 3D position and volume. Here simply call play sound with our tree fall, position and volume. And lastly, let's go public void play item pickup with position and volume, and simply go play sound item pickup position volume. Now I'm going to call this play item pickup when we pick something. So let's go to the collectible class. So in the collectible class, when we collect the item, let's play the sound. So audio manager dot instance dot play item pickup on current position. So transform dot position. Now our hatchet is also a collectible, but we have override this collect method. So here I'm going to again go audio manager dot instance dot play pickup on current position. Then let's go to the Birch Tree class. So when we destroy the tree, let's play the tree fall sound. So audio manager dot instance dot play tree fall on current position. And now for the X impact sound, currently we are only hitting trees. So I'm going to go to the Hatchet class, and in the check collision method, when we're hitting something, I'm going to play the sound. So audio manager dot instance dot play X impact on the current position. But let's say we have different sound when we hit the tree, like stone wall, etc. So if that was the case, I would go to every damageable. So for example, this birch tree cut, where we take damage, I'm going to call audio manager dot instance dot play X impact on current position. Then in the birch tree, I would again do the same thing, and if I had a stone wall, I would go play stone impacts, and like that. But right now we only have trees, so let's go back to the birch tree cut. We don't need this, and we also don't need to print log. Alright, let's test. Okay, so let's pick up our X. Yep, the sound played. Now let's cut down this tree. Yep, the impact sound is playing. And when the tree falls, yep. And let's pick up the stump. Yep. Let's chop down this tree. Let's pick up the log. Let's pick up a branch. So yep, our logic is working. Okay, that's cool, but now we have one tiny issue with X swing sound. And if you're wearing headphones, you will be able to hear. So let's say if I'm moving sideways and I play the swing, yep, I'm only hearing the sound at the left side, and if I move in the left, I'm only going to hear the sound in my right ear. That's because this audio source.play clip at point will create a game object with audio source attached at this position and play the sound. So if we're constantly moving and if we play the sound, the audio source object will stay behind. So to fix that, I'm going to open my Hatchet prefab, and in the Hatchet visual, I'm going to attach a new audio source. Then here, simply uncheck play on awake. Then here we can adjust the priority, volume and stuff, our 3D sound setting and so on. But that's all cool for now. And if I had only one audio clip for this wing, I would basically assign it like this. But right now we have multiple, so let's keep it empty. Then in the Hatchet visual, so here let's first grab the reference of our audio source. So private audio source, let's call it audio source as well. Then let's grab that on a bake. So audio source, get component of type audio source. Then let's head back to the audio manager. Then here let's overload our play sound once more. So private void play sound. And this time we will receive audio source. Let's call it source. And we have X swing clips, so audio clip array. Let's call it clips. And then we don't need volume this time. Then here let's grab the random index, so index like this. Then in our audio source, let's assign the clip, so source.clip equals clips of index. And then let's play the sound, so source.play. Then let's modify our playX swing method, so instead of position and volume, we will simply get audio source. Let's call it source. Then here, let's get rid of position and volume. I'll simply go source and my audio clips. Then let's head back to the Hatchet visuals. And now instead of passing the position, I'll simply pass in my audio source. Just like this. Also, I forgot to mention in the audio source, set the spatial blend all the way to the right, so we want to play 3D sounds. Okay, let's test. Alright, so let me grab the Hatchet. Now I'm moving. And now you can see or hear that our issue has been resolved. Awesome. Alright, now when we hit our tree, I want some kind of visual representation that we're actually damaging the tree. So for that, I'm going to use a decal. So first, let's head over to our RP settings. And in the PC renderer, hit this add render feature button and then apply this decal. Then let's set the max draw distance to like some smaller amount, 50. Then in our scene, let's create an empty object. Let's call it put decal. Then here, let's add a component, URP decal projector. Then in this material slot, we have a nice material in our asset, mobile white Birch Tree material. So we have this cut decal. Let's use that. And let me set up the tree decal. And let's set the width and height to some smaller amount. So 0.2, 0.2, 0.3. So yeah, something like this looks nice. And again, for the draw distance, 50. And let's make our put decal as a prefab. Then once we hit the tree, I'm going to instantiate this decal. So here, let's delete it. Let's create a new script. Let's call it decal visual. Then let's attach it on our tree and cut tree prefab. So select Birch Tree. Let's add component decal visual. And for the tree cut, same thing, decal visual. Let's open our script. Let's wrap it in the namespace. And here I'm going to instantiate a prefab. So first let's go class field, private transform decal prefab. Then let's create a method to instantiate our decal. So public void set decal. Now here we have tiny issue. Let's go to our Hatchet script, and here in the check collision you can see that I'm using overlap box. So with this approach I won't have hit position, so I don't know at which position I hit the tree. So one possible approach is if I use a box cast, but the problem with that is our hatchet is a melee weapon, and when we swing the weapon there is a chance that we can hit multiple objects in front of us. So this overlap box makes a lot more sense than a box cast. So the question is, how do we get the hit position? So let's go back to the decal visual, and here I'm going to cast a ray from our camera in the forward direction in like 3-4 meters. So first we need reference to our camera. So I'll go private transform camera transform, and let's grab that on a bake. So camera transform equals camera.main.transform. And now this is bad, but currently we only have a player, not even NPC bot, so let's stick to this for now. Then in the set decal method I'm going to go float max distance equals, let's say, 3 meters. Then here let's cast a ray, so physics.raycast from camera's position in camera's direction, so camera forward. Then let's get the result back, so out raycast hit and max distance. Then here let's check if hit.collider not null. If it's not null, we have hit something. Now here there might be a chance that we accidentally hit something other than our current object. So let's check if we have hit the current object. So our decal visual is sitting on the tree, so simply go if hit.collider.gameObject equals this game object. If so, we'll hit the current tree. Here I'll simply instantiate our prefab on hit position, and for the rotation I'm going to use camera's rotation, so camera transform.rotation. Then for our newly spawned decal, let's make it the child of our tree. So let's grab the reference here, so transform decal, and then simply go decal.setParent equals our current transform. Then let's call this method from our Birch Tree methods. So here let's grab the reference, so private decal visual. Let's grab that on a bake, so decal visual equals get component of type decal visual. Then here when the tree takes damage, let's go decal visual.setDecal. And I want to display the decal on the Birch Tree cut as well, so again same thing. Let's grab the reference here, private decal visual. On the awake, decal visual equals get component of that decal visual, and when we take the damage, simply go decal visual dot set decal. Then for our Birch Tree prefab, in the decal visual we will have this decal prefab slot, so let's drag our wood decal here. And same thing for our tree cut version. Now currently both of them shares the same decal, that's because they are basically the same tree. But let's say if I had a stone node, so for that I could use the same approach, just change this decal prefab to match the stone, and it will work just fine. Alright, let's test. Alright, so let's pick up our hatchet. And let's walk up to the tree. And there we have our decal. So our logic is working. And let's cut down this tree. And here we have a decal as well. So yeah, our logic is working pretty cool. And I think we should also spawn some particles when they hit the tree. So let me just quickly create particle system. Let's call it wood particles. Then let's set the duration to, let's say 0.5. Then let's set the lifetime random between two constant. Let's set fairly short lifetime, so 0.2, 0.4. And start speed random between two constant. Let's try 2 and 4. Then for the start size, let's set to a small number, so 0.02, 0.04. And for the rotation, 0 to 180. Then let's set the color to something like this. Then in the emission module, let's set rate over time 0. And let's spawn our particles and burst. So for the count, let's again go random between two constant, 8 and 12. And let's modify our shape. So and now I'm going to spawn this wood particle with the rotation of our camera. So if our camera is looking in this direction, the Y will point in this direction for our particle as well. So I want the particle to fall behind it. So let's change the rotation to something like this. And in the renderer, let's create a new material. So in the materials, let's go create material, wood particle. And let's select the shader URP particles. Let's go unlit. Then in our wood particles in the renderer module, let's set our material here. Let's change their size over life. So size over life. And let's select this curve. And I think this will work. So let's make our wood particles as prefab. Just like that. And let's get rid of it from here. And now the question is, should we create a new script to spawn our particle? That would work, but in my opinion, the decal and particles are tightly coupled. So let's go to our decal visual. Here, I'm going to create another prefab, particle prefab. And here, simply spawn our particles. So instantiate particle prefab on hit point and camera's rotation. Then in our Birch Tree prefab, let's assign our particle prefab as well. So with particles, and same thing for our tree cut. All right, let's test. All right, let's grab our hatchet. Let's hit this tree. And yep, we have our particles, but they're going up and they're constantly looping. I don't want that, so let's first set the properties here. So this is my wood particle. So let's rotate it further down, so something like this. Okay, this will make sense. So let's copy these. Then in my wood particle, let's go to the shape module, and in the rotation, let's paste that value. Then let's uncheck this loop. And now I also want to destroy our particle after this duration. So for that, let's create a new script. Let's call it particle destroyer. Let's attach it on the particle prefab and open it up. As usual, I'm going to wrap it in the namespace. Then here, let's grab the reference for our particle system. Then let's grab it on awake. Then here, I'm simply going to destroy the particle. So destroy game object after our particle's duration expires. So particle system.main.duration. So this simply means destroy this game object after this amount of seconds. Alright, let's test again. Okay, so let's grab our hatchet. Let's cut down the tree. And there we have our particles. They're not exactly pretty, but that will work for now. Let's cut this tree. And yep, our logic is working just fine. And there we have a nice tree chopping mechanism. And now I have a favor to ask. If you enjoyed this video, hit that like button, share the video with your friends, and most importantly, if you wish to see more of these in the future, let me know your thoughts in the comments. Because lots of efforts have gone into making this video in comparison to my regular shader tutorials. So do let me know whether you wish to see game mechanics or should I stick to the shader videos. It will help me to decide where to take this channel in the future. And if you've learned something new and if you wish to support me, you can check out my Patreon. Alright, that's it from me, and I'll see you in the next one.